Good morning and welcome to day 5 of Advent of Code. If you haven't seen Advent of Code, this is today's challenge. Let's get started and read the problem. Day 5. If you give a seed a fertilizer. You take the boat and find the gardener right where you were told he would be, managing a giant garden that looks more to you like a farm. A water source. Island is the water source. You point out that Snow Island isn't receiving any water. Oh, we had to stop the water because we ran out of sand to filter it with. Can't make snow with dirty water. Don't worry, I'm sure we get more sand soon. We only turned off the water a few days, weeks. Oh no, and his face sinks into a little horrified realization. I've been so busy making sure everybody here has food that I completely forgot to check why we stopped getting more sand. There's a ferry leaving soon that is headed over in that direction. It's much faster than your boat. Could you please go check it out? You barely have time to agree to the request when he brings up another. While you wait for the ferry, maybe you can help us with our food production problem. The latest Island Almanac just arrived and we're having trouble making sense of it. The almanac, your puzzle input, lists all of the seeds that need to be planted. It also lists what type of soil to use with each kind of seed, what type of fertilizer to use with each kind of soil, and what type of water to use with each kind of fertilizer, and so on. Every type of seed, soil, fertilizer, and so on is identified with a number, but numbers are reused by each category. That is, soil 1, 2, 3 and fertilizer 1, 2, 3 aren't necessarily related to each other. For example, then we get our test input. So we have seed numbers, a seed to soil map, a soil to fertilizer map, a fertilizer to water map, a water to light map, a light to temperature map, a temperature to humidity map, and a humidity to location map. Good God. Okay, the almanac starts by listing which seed needs to be planted. 97, 14, 55 and 13. The rest of the almanac contains a list of maps which describe how to convert numbers from a source category into numbers in a destination category. That is, the section that starts with seed to soil map describes how to convert a seed number, the source, to a soil number, the destination. This lets the gardener and his team know which soil to use with which seeds, which water to use, etc. Yes. Rather than list every source number and its corresponding destination number by one, the map describes entire ranges of numbers that can be converted. Each line within a map contains 3 numbers: the destination range start, the source range start, and the range length. Okay, consider again the example. Okay. So the destination is 50, the source is this, and the range is 2. So this is 98 and 99, and this will be 50 and 51. Okay, the first line has a destination range of 50, yeah, okay. This line means that the source range started, yes, exactly. The destination range is the same length, but it starts at 50. So the two values are 50 and 51. With this information, you know that the seed number 98 corresponds to soil number 50 and that seed number 99 corresponds to soil number 51. Okay. Okay, so the exact offset is there. So you have to calculate the offset between those two. So okay, that is fine. So basically you have an offset and a range for where it works. The second line means that the source range starts at 50 and contains 48 values. 50 till 97. Yes, okay. So seed number 53 corresponds with soil number 55. Yeah, okay. Because that is the same. Yeah, okay. Any source numbers that aren't mapped correspond to the same destination number. Okay. So number 10 corresponds to soil number 10. Okay, so if it's outside of the maps, okay. So the entire list of seed numbers and their corresponding soil numbers looks like this. Blah blah blah, okay. With this map you can look up the soil number required for each initial seed number. Okay, the gardener and his team want to get started as soon as possible, so they'd like to know the closest location that needs a seed. Using these maps, find the lowest location number that corresponds to any of the initial seeds. To do this, you need to convert each seed number through other categories. I'm having trouble with that word. Until you can find its corresponding location number. In this example, the corresponding types are etc. So you have to go to the entire chain. So the lowest number is 35. What is the lowest location number that corresponds to any of the initial seed numbers? Okay, so this is a real pain in the behind. So let's start input parsing. There's a lot more work than I thought for today, but okay. So we need to parse this out, and I'll need to have the mapping rule here as well. Let's see. Let's put this here. Destination range start, source range start, and the range length. Okay, so this is always just 3 digits for these. So let's override the input and set it our test input here. And we need to process this input. So we do input.split by and this is like double new line. This is for the test input because I think since I'm on Windows, I will have the carriage return once. The real input will only have new lines, so I'll need to account for that as well. So far, sections is this. Let me see, because I have my extension to lines, and this will remove the empty one, so that's not useful there. Okay. So that will work. Okay. This should be 1, 2, 3, 4, 5, 6, 7, 8 sections. Console, right line. Let's check. Sections. This to array. I had this in release mode to do a benchmark yesterday. So let's switch it to debug. And this gives us 8, so that is fine. And now we need to do all the mappings. And I wonder if I'll make a class for that. So public class range map. Boom, 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 boom. Public int destination from to, same for source, source from and source to. Length like this, and we can have some helper functions in here to determine if a value is within the range or not, etc. So we do public range map, and we do string raw. We can also do a constructor that does public range map, and then we do int source. No, destination, it's first destination, right? Int dest, int source, int length. And we can do destination from is destination, destination to is dest plus length minus 1, because yeah, if you have a length of 2, you end at 1 more than the start. Same for source. This is source. Source 2 is source plus length minus 1, and length equals len, like this. We can have all sorts of functions here, like public, enumerable, int, source, range, get, and then you do for int I is source from, I smaller equal destination from, like this, exactly. So if we need to iterate over it, but I think the ranges might be very big, so this is probably not feasible, but I'll write it out anyway. Destination range. This is also funny. I let it autocomplete and it gives you the wrong code, so that's nice. Always gotta keep paying attention. So yeah, and now we just need to do this. So this will be, can I do a destructuring here? Probably not, right? As 32s. Are they spaced out? Formatted? probably. No, they're not. Okay, that is good. So we can just use this. Because in other language you could do like destination from and source from length. You could do it like this and have it destructured to array. Right? I don't think we can do that here, right? No, okay. That is fine. And I can do it would have been fun if I could call it what I can do is like this. Let's not mess that up. Values like this, and then I can do this values 0, values 1, values 2, like this, and then I can just do like this. Not sure if that's the best way, but I'm going with it for now. So now I have something to parse out and map the ranges. So now the first one is actually our seeds. So we do int seeds is sections 0 dot as int 32s. Sorry, like that. So these are our seeds. Actually, we need to skip a section. Let's just I'll just add another function here. Public static string skip this string input string target. So now we can do int x is input dot index of target. If index larger equals 0, return, actually if it's larger than 0, return input dot substring x plus target dot length, because we want to skip it. Else if return input, because if the index starts at 0, we don't need to skip anything. If it returns -1, we don't need to do anything, so we can just do this. So now we should be able to say sections.skip, and then we skip this header part. So we strip off this first section. We could also just split on that, but I like this part because it will probably be useful later. And now we have all sorts of maps that we need to do. So we have soil to seed to soil, seed to soil, soil. And let me zoom in a bit to fertilizer. Drawback is that I can't read everything if I zoom in this much. Soil to fertilizer, fertilizer to water. Water to light, light to temp, temp to humid, humid to location. Okay. And what we probably should do is find like a reverse, go from this one back and do like entire paths, but yeah. Let me see how big the source is. I don't know. I don't know if that's the best way, probably, but see, these are big numbers. So yeah, that's fine. So what you could do is actually map out all the paths with new ranges, but yeah, let's just do it step by step from once. And this will actually be a list for each of these. So we do seed to soil is, and then we do sections. One, actually we can do int ix is 0. So let's do this here. So seed to soil dot skip 1. Now this needs to be 2 lines. Skip 1, and then select new range map to list. Okay, and this becomes X like this. So now we have the seed to soil map, and we need to do this for each of them. So now we do soil to fertilizer like this. Fertilizer to water is this. Oh, come on. Water to light is this. Light to temp is this. Temp to humid is this. And then humid to location is this. So that's everything parsed. Let's set a breakpoint here and inspect our data to see if it's exactly as we expect it to be. Boom! The input string was not correct. Okay, it's trying to parse something here, which is funny. Call stack. Let's see. Okay, let's see what my code returns here. So we do sections 0. Let's skip this. Let's not do a typo. So that is fine. What is the issue here? I need to split. Actually, let me see I need to remove. As you can tell, I'm not fully familiar with my own extensions anymore. Is this? This will do the char one. I need to have an IEnumerable string there, so I need to split it first. I made that one so that you can treat each character in the string as an int. So that's an important distinction here. So you need to split on space, and that should be it. So if I run this again now, Ah, it will take the wrong overload. That's annoying. Let me see. Am I in the wrong section here? The range map there. Ah, okay, I need to also do this. Dot split. Split. Like this. Okay, almost there. Okay, let's see. We have seeds to soil. We have two ranges, 50 to 51, etc. Okay. It also does that correctly. Then 56 till 92. Okay, great. Something that we still need to do is the offset. So if we go from seed to source, let me see. Because you go from left to right, right? You take this and you want to map it to a destination, so you need to do this. And you need to diff those. So let's see. So what you need to do is, let me think. You need to do destination minus source as the diff. So do public int source to dest diff get. This, and this becomes this destination from minus source from. I think that is correct. So let's do some of the test input and see if that works. And then we need to find, actually from a list of those, we need to find the correct mapping. So we need to have a helper function. So we do public static int get destination int source, and we do list of range map ranges. So now we need to do var match is ranges dot where r dot so we need to go source from is larger, smaller or equal to source, and r dot source to is larger or equal than the source. Single or default, because we can't have more than one match, because that will be invalid range. So if match is null, return source, else return source plus match.diff. Right? So this will give us a mapping from the source to a destination. So what we can do here is for each int seed in seeds, like this, and then we do console write line seed like this, seed, and then we do range map dot get destination seed, comma, and then seed to soil. Right, and this should give us the values for the first step. So let's see if this maps to our output. Let's see. And of course they don't have the exact values here, right? They don't show it here. Oh no, they do, actually here. 81, 14, 57, 13. So yeah, that is fine. So now what we need to do is to transform that entire path along all those steps. And what I can actually do is turn this into an array and set them all in order so that you can just loop the entire array to walk the entire path to find our destination. So we can do this transforms is new blah, and then we add seed to soil, soil to fertilizer, fertilizer to water, water to light, light to temp, temp to humidity, and humidity to location, right? So now we have all the transformations mapped. So what we can now do is actually for int I is 0, I smaller than transforms.length. Actually, let's set it here. And it's this, len, increment I, we can do int s is seed, and we do this now. Let's see. Let's just do this. N is this one. But instead of getting a fixed one, we'll just get the next one here. So we do transforms I, this becomes S, and now we do like this, S becomes N, and now we do S is N, like this, and then we are here, console.writeLine, we do an empty line after each step. So this one gives us the full path for everything here. So now we could do the end results and see if it works. So 35, 86, 43, 82. Okay, so now we have tested all our code and it's correctly. So now we can run the real input and see if that works. Let's not print out all this data. I think we need to keep track of the lowest destination number, right? The lowest location number, okay. So let's keep track of that. Int min, no, let's do, actually, yes, int min length is int.max value. Max value. So here we do if s smaller than if min length is s. Now we do console, this will be part 1. So do part 1, min length. Okay, so let's run part 1. Okay, we have overflows. Okay, I was thinking about that, but yeah. This will become actually as int 64 is done. Do I have that as int 64? I have that. Okay, so let's make sure that we as int 64s, and this becomes long, which is fine. This all becomes long. Boom, boom. I looked at the input before and I was like, and I still didn't do it, so boo on me. But it's fine. This also becomes, and we don't even use this, and I think I'll just comment it out for now, because if a debugger gets the property, it will produce a lot of data. So we don't want that. This becomes a long, this becomes a long, blah, blah, blah. Everything is correct, except that it doesn't like this. This is as int 64s. That is good. This also becomes long, long. Oh, and now we should be in business. Oh, was a bit. Input string seed to soil was not in the correct format. Okay. This is exactly what I said at the start. The input actually uses not Windows new lines, but so what I need to do here is to just use my 2 lines. No. Why is my PC is acting a bit weird? Let's see. I need to. It's like the control key is held down or something. When I press home, it just jumps to somewhere else. Okay. This is so annoying. I'm not sure why this is happening, but it's annoying because I always use like all the home and end keys. But let me just do it like this for now. I can't do that anyway. Okay, that's weird. It's like there is a control key or something stuck. You know what? I'm gonna kill Visual Studio for now and restart it. That's a new one. I should have like this. Please stand by while we're having technical difficulties. So close to getting the first star. Can I use home and end? Yes, okay. So Visual Studio was bugged and I've never seen that before in that way. So that is very interesting. It detected like the control key was being pressed while it wasn't. So everything turns into a special thing. Okay, so let's run this again. Now with the proper line endings. And we still overflow. That's not good. How is that possible? That is interesting. Okay. What could that be? So probably one of these is wrong. Let's actually let's do it like this and check out the transforms that we come up with. Like here, the source to des difference is big. Let's see. So that is a negative jump, which should be fine. Let me think. Let me think what goes wrong here. Because there can't be any negative mappings, right? Because somewhere I go negative here and that's not possible. It's interesting. Because it should not be possible. Get destination. Well, of course you can do get destination, but so what happens if you map onto something that just sends you out of bounds? Let me read the input, the text again. Source mapped that aren't mapped. Yeah, that is fine, but let's see. The first line has destination range of that. The source line starts at there, and the range of this. This means that the source range starts there. Yes. You know that the seed number 98 corresponds to soil number 50 in that seed number. The second line means that the source range starts at 50. Okay. Any source numbers that aren't mapped correspond to the same. Yes, okay. But if my mapping returns actually what I'm doing is not possible. because basically it says you need to remove the difference there. Okay, wait, let me see, because this is a flaw in my logic, I'm sure of it. Because let me look at the negative one. Because basically what it says, yes, because the value that maps, because it always maps to a positive number, so I don't understand that. Because we come from source this, so our value is within this range, right? Between source from and source to. And then you remove that to go to this destination range. You can't go negative, so how is it possible that I went negative? So did I overflow somewhere? Let's just step through this for once and see. Here, it already happened. Okay, wait, stop. Let's go here. Set next statement. Seed. S. Wait, what? Set next statement. Ah! Do you see what I do here? I'm such an idiot. And this is something that I think the compiler could warn for, but seeds is a set of longs, right? But in my for each loop, I specify int. So this is the one place where var would have saved me, because it would cost to keep the type as long. But here, it said int, so it didn't cost to int before looping. So that, yeah, that's something to that's something that I don't really like about this. Because I think you should have. Well, it's my mistake. That's first, but this is just something that's really annoying. So okay, this should be the answer. Let's just put it in and move on to part 2, because I can rant on this for a while. Woohoo! Part 2. Star earned. Let's see. Everyone will starve if you only plant such a small number of seeds. Reading the almanac, it looks like the seeds line actually describes ranges of seed numbers. The values on the initial seed line come in pairs. With each pair, the first value is the start of the range and the second value is the length of the range. So in the first line of the example above, this line describes 2 ranges of seed numbers to be planted in the garden. The first range starts with 79, contains 14 values, etc. Now, rather than considering 4 seed numbers, you need to consider a total of 27 seed numbers. In the above example, the lowest location number can be obtained from seed number 82, which corresponds to soil 84, fertilizer 84, water, etc. Yes? Consider all of the initial seed numbers listed in the range of the first line of the almanac. What is the lowest location number that corresponds to any of the initial seed numbers? So this is a problem, because as you can see, these seeds here are huge. So if you would loop through all of them, it will be a giant pain. So what you probably need to do is build these ranges, then find every mapping within that range and follow those. And then you have to. So this is a complicated one already, because you have to keep finding all the ways it could separate, because yeah, you have to map out ranges and then do sub-ranges for those. So this will be a bit of a pain. Yeah. Okay, let's see how we code this. I really think the difficulty this year is very high, because it's like normally the first week you don't even have to think about things. It's like solution done. So yeah, this is really giving me some pause already. So each of those becomes a range. So yeah, as I said, for the seed numbers, you will have to find out like the inverse. You have to find for each range map that you have to do in which ranges they will fall, and then map out the corresponding ranges. And then for those ranges you need to do, you need to separate into all of the ranges that can possibly happen. So, and this is a bit of a challenge. So let's revert back to the test input for now. Let's just take this code for part 2 now and re-enable the test input. I can remove this comment here because I already have it here. Like that. So we need to convert these into ranges now. So this is all fine. Let me just remove this code. So now we do for int I is 1, I smaller than seeds.length, increment I. Console, right line. Hey Smap UK, good morning. Did you do the challenge already? Part 1 was a breeze, except for some long conversions. But this one is a bit of a challenge, having to map out all these things, but it will be fine. So we do seeds, actually, let's do it like this, long from long to length. Yes, okay. Did it take you a long time to do part 2? So we do from is seeds I minus 1, 2 is seeds I, length is 2 minus from. No, actually this is wrong. This is from plus this one. 2 is from plus this. So actually length is actually this one. Let's see. Turns out I had the answer for ages and I didn't realize it. Okay. Yes, it took me longer than it should have. Okay. Let me see it too. Okay, so do from to plan. This. For the test input it was all length 4, right? No. Let me see what I'm doing wrong. Ah. Good morning. Yes, so you have all of these. I've been refactoring and somehow I've broken my test cases, but I still get the right answer for the meaning. Well, that's interesting. So there's something wrong with your tests now, or you're too strict and it doesn't trigger in the real value. So yeah. Now what we need to do is have a function that says get destinations source from long source till, and we do matches and actually we do range map. Come on. Get destinations. Bum, bum, bum. No, I need to cross these actually, because it's a window. No? Let me see. I'm going to leave that until later. I was stupidly up all night and I'm going to bed. Okay. Ah, you tried to get on the leaderboard. Okay, I'm not that dedicated myself. Let me see. Because this one will only return ones that fit the entire window. That's not what we want. We want something where source from is somewhere in here. And source 2 is larger equal to this. And I think this should give us all the overlaps. Yes. To list. Let me just check this for now. No chance. Let's see. No chance. You've seen the approach in the way I write my code. That takes time. Let's see. Range map dot get destinations from to seed to soil. Maps.length count also fine. Let's see. Oh, each one of these only hits one mapping. That is annoying. Good luck. Yeah, thanks. I'll probably need it. That's annoying. Oh, I thought that the test input would have probably already given us some mappings there. Oh, and I also forget that the last one actually it doesn't say what to do with the last line, right? Okay, so it's really, the 13 isn't a single entry anymore. Okay, that is fine. So these are 3 pairs, 1, 2, 3, and that's it. Okay. It's just annoying because I already know that it will branch off for like the real input. And it's sucky that I can't test that already on the test input. So yeah, because in this case it really doesn't matter. Let's see. Because now I need to I also need to have like a clamp function. Public int long from long till clamp long from long till and this will return math.min no, actually the max from comma clamp source source from. Min, so it will be till source 2. I don't know if I need the destination here, but like this. So I have functions to split that up. So what I can do here is like for each var map in maps. Var clamp is map.clamp source, and this will be from 2. So this one will give me a clamped from. Like this. A till, I call it here. This will need a +1. And then I need to do this again. Maps is this. Get range map destination, because basically I still need to do this like the for int ix is 0, tlen is transforms length like this, but I already use like this, then also fine. So now we get transforms ticks like this. Let's start this at 1 because we already do the first there. You can probably rewrite it, but I just want to do it like this now. I can't update this inside this loop. That's interesting. I need to branch this off here. List. Because I need to keep track of all the fractions, how I'm going to do this. Actually, I do need to do it like this. Let's see, start at 0. Let me think. We get our maps. Then we have like that. And now we need to keep track of all the sub values here. So we probably need to have a list of long from long till that keeps shifting fractions. Right. So we do fractions that add from 2 in this case. And now we basically need to do these sub-steps for each entry in fractions. And then after each step that we do, we get more fractions, and we have to get rid of the old ones. And then yeah, it's a nice, well, not sure if nice is the word, but it's a challenge. probably need to turn this into a function, which basically gives us a list of long from long to make fractions. We do int transform index. I think that is also something that we will need. I think that's basically it. Let's see. And this will be the result. So we do result is new. Return result. Okay, that is fine. Let's see. So we have from to, and this will be the transform index. 2 minus from plus 1. We need to pass the transforms like this as well. Okay. Transform index like this, transform index. I think this should be fine. Okay, now we need to clamp it further, and we need to actually do add from to. Oh no, it's clamped actually. Clamped is just the same pair that I'm looking for. Yes, okay. That's interesting here. And I should probably actually. I'm wondering how I'm going to roll this up. Because basically I need to call a recursive function here to go deeper every time. And then for each of these I go deeper. Let me think. Because the thing is that the working set of values is never returned. No, that's not true. Basically what we need to do, if transform index smaller than transforms length minus 1, else we do this. So we only add it to the result if we're at the deepest level, else we do result.add range, and then we call this make fractions, clamped.from clamp till transform index plus 1 transforms like this. And this should recursively build up all the fraction data that we need. So that is interesting, I think. So what we can do here is just, instead of doing this, let's comment this out and just call our function and see what it does. We still need to enumerate this one. Let's do make fractions seeds. Okay, I was a bit like this. Actually copied too much. Let's remove this. Make fractions from to 0 transforms. Okay, so var seed fractions is this. this one. Fragments into, and then we have C fractions, fragments. Let's try this. Curious to see what this spits out. 0. Nice. Okay, let's see. Man. Okay, let's debug. Maps, okay. It gives us one map. What does clamped give us? So let's see. We say from 79 to 92 for 14. This is also the same range. So that is fine. And now we don't get any maps. Ah, I still need to transform the values. Let's see. Before we do the next step, we actually need to do the transform from part 1. So this would be this part. Yes. Let me see. This becomes clamped from. Let's see. Long new from equals range vector get destination. And this will be transforms. Transform index here. No, we don't need the destiny. Actually, I need to have the offset. Right. Let me see. Well, basically, I already have the. Yeah, basically, I just wanted this, and this can be just a public long convert to dest long source. This basically becomes this. Let me see, where was I? Yes. Because I can do just map dot convert to dest, and this will be clamped from, right? So I need to add this step in here. Clamped dot from clamped till. And once this is done, else I need to actually have the transformed values in there. Oh, but these... I was thinking of preserving the original starting values, but you can't do that. Let me think. It's actually fine because we want the result anyways. I was thinking like I could go back up and then keep all the fractions and then do that, but it doesn't matter really. So I can just do this. I will add this as the result values, which is fine. It's fine. No. Okay, let's stop. I can actually make this a pair too. this. Boom. So I can just do this. And then I don't need to do it everywhere because I already converted it. Like this. The right lines will not be as clear, but let's see. Still 0 fractions, that is great. Okay, let's debug it. So now the range is different, okay. I need to step into that actually. Set next statement. So let's step into this. So this one doesn't give any values. 0 to 81 to 94, which is interesting. Shouldn't it trigger this one? Let's see. Set next statement. Jump into, let me see. Because we have 81 and 94. So we want all the ranges we're sourced from. Let's see. Okay, so this is fine. So we don't get a match, that is actually fine, but then we just need to do something else. Also, I just realized I need to make sure that the entire source range is mapped to the output range, because not everything has to line up exactly. So, so we have to do list in long from long till covered is new blah. And we need to remove this like this. Cloud. Okay. Here we need to do covered add clamp. I need to make sure, because I think this will work. I just need to make sure that I check it just to be sure. And now we need to do I need to make sure that I check everything that's covered, that's not covered, that also gets a value. So let's see, if I order all the ranges, so I do covered, that's sort. Does that work? I think I just do like this. This doesn't return, right? Yeah, okay. And I need to make sure that this ordering is correct, so let me just run this first. come on, I need to have a breakpoint here. So clamped is that. I won't know because this one won't change, but yeah, okay, it's fine. Let's see, covered, and I also won't know because this one doesn't have it. Wait, what? Why is covered not set here? Ah, because I'm jumping into and out of it. Yeah, this is nice and annoying to debug because it's a recursive function. So it's actually a step deeper now. We were here. So let me just check this and just add a new one. Dot add 5,10 like that. So now covered has 2 entries, and if I now call this sort function, quick watch, sure. Is it in the same? Okay, so the sorting is at least correct. That is fine. And now I need to go for long start is from, start smaller than 2. Actually no, long start is from, let's see. I is 0, I is smaller than covered count, increment I, because I need to make sure that I fill up all the values that aren't in that range with exact maps, which is really annoying. So long min is from current is covered dot I. If current dot from is larger than min, then we need to have a result dot add, and this will be min comma current dot from -1. This will cover that gap. And now we do min is current dot till. Yes. Current dot from is larger than minus. Actually, we will need, the min will be what's covered +1, so this is correct. So if there is a gap, fill that gap. So that is fine. Okay, and then here in the end, if let's see, if min smaller than 2, result.add and this will be min comma 2. This will fill up all the holes here, but this also needs to be in the same logic here, like what we do. So in both places we need to make sure, let's do bool is final step equals this. Is, let's see, not final step, because we checked if it's smaller, which is fine. Not final step, so then we can use that here as well. If it's not final step, okay. And we need to do that here as well. If not final step, and this is our else logic, because if it isn't the final step, we still need to do this, and then we get min the same values here. Boom. Okay, and this will be min up until 2. This is such a lot of work. So let's see if we get some results now. Seed fractions. Hey, we actually got values. Woohoo! So this produces 3 ranges: 60, 64 to 55, and 82 to 84. Okay, that is for the first one. Jesus, let's see. The lowest from seed number 82, which corresponds to soil 84 for the. Okay, so the lowest. Okay, let me just run this for everyone. So I need to do. Let's see. So here I just want to do the add range seed fractions, and now we should have console.writeLine part 2. We do seed fractions. No, seed fractions. Come on. No, it's results.min x.from. So this should give us the lowest value. So let's see if it also works like that. 1. That's not correct. Damn it. Okay. Let's see if we can spot something from this logic. The line start with 79, contain 14 values, yes. The second range starts, yes. Now, rather than considering 4 seed numbers, you need to consider a total of 27 seed numbers, which is correct, yes. In the above example, the lowest location number can be obtained from seed 82. So I need to follow the path for number 82 here. So let's just debug that. I said let's debug that. Okay, so this one has the one that goes up to 82. So let's follow that one. This range, fine. So what was the path again? Let's say. So we have 82. 84, 84, 84, 77, 45, 46, 46. Okay, so that's the path that it needs to go to, right? So 1, 2, 3, 4, 5, 6, 7, 8 steps. That is fine. Okay, we're currently at transform index 0. So we go from the first 82,
is it going in the right direction? Yeah, we went from 79 and now it goes up 2. So that is fine. So we go one step deeper. So now we still need to be 84 because there is no map, I think. Right, so that is fine. So let's see. Min is smaller than 2. Yes. So this one gets us to our next step, which is fine. So we have 81 to 92, which is good. Do we have any maps? No, which means that it still stays like this, which is fine. Which gets us to the next level. Is there any maps here? Yes. So that shifts us down 7, as we can see from the logic here, like the map that we found. The difference is 7, and that's also like what you can see here, so that's fine. So we have here 81 to 94. So this one becomes covered 8194. Now this one is altered, it should be 7 lower, which is good. Let's see if covered is altered here. No. So it's because it's a value, not a reference type. So that is good. So now we're in the new range, which is good, from 74 till 87. Right. So we're still good. Now we need to jump to 45, so we should have a negative map again. Minus 32 and plus 4. So we need to hit the minus 32 one, I think. We have 74 to there. Okay. 74 to 77 is good, because this one is the one that we want. Okay, let me just check once more, like the map. Yes, this goes from 77. Okay, so that is also the jump that we need to take, which is fine. So we have covered here this section. It's not the final step, so we're now in the 45 to 55 range, which is good. It's the same range. Now we jump to 46 to 56, that is fine. Let's see, what is this map? Wait, did I miss something? Did I not pay attention here? Ah, this is the second loop, the second map. That is not a problem, but I think I'm in the wrong path now. Oh no, it has added that one here, because it's the final step, and there's a 46 to 55 here. Okay. So basically what I need to know is which path, and then trace that all the way back, which is annoying AF. Gives a number lower than 46. 85, 96, 66. Wait. How can it say... Okay. So that happens earlier on then. Because I followed the path that should work, and that's okay. So let's just run it again. Here, this one. Where does that one come from? 1 to 18. Because that one isn't correct, apparently. Oh, there's also a 36 here. So I think it's somewhere. So there are two values in here that shouldn't be here, and there's also a 20 to 21. So 3 values in here that are not correct. So let's find out if we can see why that happens. So we're getting there, but not quite. Let's see. It's probably... No, let's not speculate. If min smaller than 46, system.diagnostics.debug broke. Alright, we do the same here. We do the same here. If clamp.min from like this. Okay. Okay, let's see. What does covered hold? Nothing. The from, it's 20 to 21. Okay, let's note that. 20, 21. Let's see if we can find where this comes from. This one has 19 to 20. Another 19, 20. 26 to 27. At least we can trace it back. 37 to 38. 52 to 70. And this one is 14 to 68. Okay. So let's see if we can find out in reverse what's going wrong here. So the seed values here, it should be 14 to 55. So why does it say 14? Oh no, it's 14 with the length of that, which is correct. Okay, 14 to 68. Okay. Let's just do it manually. 14 to 68. That splits off here, so that's understandable. Let's just debug this right the way up here. See if we can find the error. Let's see. The seed is not this one. 14 to 55 to 68. Yes. Okay. So this one will go from 52 to 70 as a match. So let's see. Source from, source to. Okay, so that's a bit, that should fully cover it, right? Let's see. Because clamped is 50. Oh, this is 14. Ah, yeah, okay, my bad. So it's that range. So why is it 52 to 70? What's the offset? Ah, it's 2 here, okay. So let's see. I think that should be fine. So 52 to 70, that's the path that we find here. And I think that's also correct, right? Yes. So that is this rule that it matches, so that is fine. Yes, so we step in here. What does it match? Just one. It's a minus 15 step. So that would be this. I just wonder if there's a... Let's see, because this is a narrow map, right? This one is 52. Is that a length of 1? No, length of 2. So 52 and 53. That goes to 37. So yeah. I think that should be fine. I wonder if I just run like the individual numbers here, if I generate all the seed numbers, if I come up with something different. But yeah, let's just make sure we step through this. Let's see, map. So this one is the smaller section here. Let's see. Because clamped is now this. Just trying to see if I can follow it here. Because 37 to 38 in here, it should match this one, right? Let's see. Yes, it should match this one. There's an offset there, okay. Ping chilling. Hi Nick, hi, welcome. Let me see. So the next one should go wrong here then. Probably. Let's see. Maps, it will find a 1. Is this the one from 0? Yes. So why doesn't it... Oh no, it jumps here, that's good. Yeah, I'm doing part 2 and I'm getting a few values that are too low. So I'm just trying to figure out if I can find what the problem is. So I've traced back the issue. So it should now do this jump, so to convert this range from 37 to 26. And after that it does another jump, and after that it never gets out of it again. So I need to figure out where that happens. Let's see. Oh, part 1 was great. At least I think so. Basically it's a long map, so these are the seeds that you have, and these are mappings. So like from this you jump to this, so it's this minus this is your offset, and this is the length of the range. And I just wrote out some code. So I have a range map here, and it has a destination from to, source from to, length, and the difference between the two of them. I have some code to parse the input strings here, so you can take the raw string, dump it in here, and then it will fill all the data. And then I have some helper functions to map out matches. So that worked pretty well. So part 1 was fine, and then I set up all the transforms here. I put them in an array, and I just looped through all of the transforms. So part 1 was fairly straightforward, even though it's a lot of code to get it done. But for part 2 you need to reinterpret these numbers here. So these are now not individual numbers but pairs. So 79 with 14 after that. So yeah, and because those numbers in the input are huge, like here, if you would actually generate all those numbers, it would run for very long. So what I did was actually write some code to turn all those things into ranges. And that's what I'm doing here, like make fractions. It will take a range and the current step that you're at, and then just see for each of those values how it would separate into the next set of maps. And that's what I'm debugging now. So let's see, I need to go here. And I was debugging, but let me see. Interesting approach. Yeah, well, I think it's the only way to. You could probably brute force it, but I figured that I need to, instead of considering every individual value, consider the unique path that it can take, right? And that's something that you probably have to do for a lot of these things, just to make sure that you don't run, because like you only need to know the lowest number. And you need to perform all these transformations. So if you just take all the unique paths that those ranges of numbers can take, it should lead you to the answer fairly quickly. But here I have a condition where the answer should be 46. And I get 46. But I also have 3 paths that end up in my results that shouldn't be there. So now I'm just trying to debug the code to see what the reason for that could be. And this is funny because I don't know how we get here. Final step from till. So I got a path here. And I think I made a mistake there. That's the only downside of having recursive code. The debugging can get quite interesting because there will be branching paths and yeah. So now I ended up where I was debugging this and I didn't pay attention good enough so that it happens here. So I need to probably make sure that these fill steps are correct, because I think that's where it's coming from. So let me just do this. Actually, I need to make sure that I am in the right path. So yeah, for this, yes. So this is the path that I really need to pay good attention to. Let's see. Wish you all the best. Yeah, thanks. This is always the pain. Like coming up with the solution, it's okay, but it can be a pain to debug. Boom, 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 boom. I already have this, so that is fine. So let's see. No, what is 2 here? 20. Okay, so here we have a path, and I think this is this path. How did we get here? So there was a map here. A map here that goes from 25 to 94, and it's 26 to 27. So that's weird. Let me see. 26. Ah, okay, that transforms into there. Let me see. Boom, 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 boom. So just 26 and 27 is the path that goes in. So that is this step here. The thing is, I don't know why this happens or shouldn't happen. This is very difficult to debug. Let me see if I add some extra output there. Let me see. Let's see. Because what I can do is I can write out which parts map to which parts here. This becomes clamped. No. Like this. So this will show me the mapping. Just trying to new string. Can I do T, comma, yes, you can do that. So I'll just indent it with tabs for every level of the transform index here. Let me think. Trying to see if it already spits out some meaningful info for me now. Because this is basically this is this range, then it goes to that range, 7 to 70, 30. So this is the part that I was trying to figure out why it wasn't working. The only thing is that I can't tell where it branches off in a path that isn't correctly. So I should probably do it by hand, which is annoying. Actually, let me try something else. Let me just do the part 1. And let's do this. Seeds. For int, no, long axis. This. X smaller than come on, I can do list long seeds like this, new. I just want to make sure that I get this correctly and see what the input should be so that I can figure this out here. Okay, so these are all of them. Actually, I can do this smarter or nicer. So I can do right. So I can do console.write. this. Then it will add all the steps. So that I can do with the double new line and not do it like that. So this should give us the path that that branch should take for every value. Oh. Let's make sure this is a string format. And let's work our way off of this. So here we can see, we can put this into text file. And now we can debug this. So we have this one is a separate path, this one follows some logic, this one has a different branch of logic, this one keeps going till here, this one moves till here. Okay. So this is quite useful actually. So you can see here for these paths, every step should be one more than the previous one. So now we can have the ranges of values that take unique paths. So we have 14, 15 to 21, 23 to 25, 26 to 43, 44 to 49, 50 to 51, 52 to 53, 54 to 58, and 59 to 69. These are all input ranges that branch off differently at some point. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9. So if my code would be correct, this is the output that I would expect, right? I would expect 9 different ranges that have split off. And I should probably check where that happens. Like, this is quite cool. So for the first set, you can see that 14, 15 follows the same logic the first 3 times, but then it branches off, right? So for 14 and 15, the branch happens at this part, right? So this is the first transformation, this is the second, and at the third, it splits off into 2 unique paths. Here you can see that 14 and 15 start the same, but 16 and up actually goes all the way to the end. So the first separation should happen at the start, where you get one that does 14 and 15 versus 16 till the end, right? So let's see if we can go back and debug this. So that was very useful, I like that. Let's undo this, because we don't need it. Let's also not write out all this crap, like that. And let's try to debug that path again. That's not the one we're interested in. We want to know this one. So we go here, make fractions. And the first map is 50 to 97. That is correct. So there should be That is the first branch of here that we just said. And then there is one that goes into here to do the not covered part, right? So in this case, I would just step over here, not do that deeper part, and make sure that we have a covered section that gets added. And this will be 14.
Yeah.
Wait,
Okay,
this is not correct. This here is the issue.
Dat is zeker geen probleem, want ik kan nou...
Because covered is actually from here till 60. No, actually it is. Wait, let me see. We go from 14 to 68.
Oké, ja, dat moet nog worden afkomen.
Did I do the first part wrong already? No.
Yeah.
Let's see. Transform index is 0. Which one is it?
Yeah.
Let's see.
Yeah. Okay. Yeah, maar dan heb je het toch niet.
Ah, we need the source there. Yeah, 52 there. Okay. Wait.
Niet probleem.
So when I did my debug here, let's see, soil map, seeds, transform this, get destination. Let me think. Because the first one, all these don't map, that's correct. None of these map here. So shouldn't there be a subtle jump somewhere in values? Let's see, around 50, right? Wait, okay, let me see. From 14 to 49, because this set had... And what was the map? What was the offset here? Was 2. So shouldn't I expect a difference of 2? Ah, okay, that's written here. Okay, so the first one we can completely ignore here.
Oké, ik moet die afstellen aan die ook.
Okay. That, okay. So there's a shift here. Okay, so this is this divide. That is fine. Okay, that is fine. So let's jump into this path. So we go from 14 to 49, which is fine. And now we have 2 maps, which is fine. That should be one for the first 2, right? And one for the other. So yeah, from 0 to 14. Okay, I thought I'd mapped 2 here. This is what this was, that unique path. And there was no match for this one probably then, right? Let's see. So this one was that unique path, and here is the one that starts to increment, and this one, okay, so this is a second just 2 divide that just keeps going up. That is also good, okay. So from 14 to 49, it will exclude 1. Oh, it will map 1. Wait, it maps 2. This one is 15 difference, and this one is plus 39 difference. Wait, let's see. Is that correct? Because this one is the minus 15 one, right? Let's see. The first one is minus 15, and then it's plus 39. So this one, where does that happen? Does that even happen? Oh yeah, there's a divide here. Okay, you can see that here. This one doesn't find a mapping. And is there one that goes up? Let me see. Maps. Boom, 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 boom. 15 to 51. And the other one is 0 to 14. So this one matches that one. Okay, so there's 2 full ranges there. But I wonder why my old code, because I can see this part here. Ah, that's this part here. It jumps 40. Is that correct? No, this one is 15. This is minus 15. Everything here is minus 15, and it goes through this entire section till there, right? 14 to 49. Ah yeah, and this is the only branch that we're covering. That is fine. 49. Okay. So why do I have a source from 15 to 51? Let's see, source decibels. It looked like I'm missing something here. No, this one is the jump up here. That's correct. I have that. So that's plus 39. That is the jump from 14 to 53. That is okay. And the other ones, all the other ones just go minus 15. So I think that is also correct, right? It covers that whole range. Sorry, it takes a bit to to wrap my head around it. So these are also still correct. So which map is this one? Is this the first one? Yeah, this one will go for all the other ones. Let's just follow that through then. So this one will go from 0 to 49. Let's jump into that path. So this one will be 0 to 34, I mean, right? Yes, so this is this section here. Okay. This one splits 3 ways. Okay. So this one will be this section that we're debugging. So the next divide will be, okay, here. So there will be this range, 42 to 48. And then we'll get one 57 to 60. And then one that will go back down to 0. Okay, so 1, 2, 3. Okay, that is also good. So this one will be just 0 to 23. So this one will be that's the range that we just set here. This part. Oh wait. This is funny. Because this one is actually one of the numbers that we saw in our output, which was incorrect that we thought. So this isn't, there's a bug here apparently. Let me check. So this is interesting. We're at transform index 3. So maps just gives us 1. And that is from there to there. Okay. What is in this range here? We're at index 3. There's one that goes from 24, from 18 to 24, and then one from 25. Okay. Interesting.
because this was actually one of the values that I shouldn't get, right? So that's curious. Because if my code produces this in part 1, that means that there is already a bug in the part 1 section apparently, because this is a path that's this isn't correct. These values here, this whole path, I think is incorrect, because this provides values that shouldn't happen. Same for this, because the correct answer should be 46, but I have lots of values in different ranges. So I have here one that ends up at 36, here from 37 to 42, from 1 to 18, 45, 44, 45. This is weird. And the funny thing is that I actually had because I don't have a 46 range here in it at all. So that's even weirder. Okay, I think this means that I need to come back to this at a later date, because it took me this long to realize that even these are all wrong. So if I process values 26 to 43, I get wrong values. So I don't know how it's possible that I did part 1 correctly. But yeah, it's strange. Let's see, because 14 input here, 14 goes to 43. That one is a correct path. Do I have 55 in here? Yes, 55 goes to 82. So that is correct. And the 55 goes to seed 55. Goes to 57. Let's see. Fertilizer 57. Then 53, 46. Temperature 42. Here is something that goes wrong. Right, am I looking correct? Let's see. 55 goes to 57, 57, 53, 46, 82, 82. Okay, now that is correct. No, wait. Location 86. I don't print the last. I don't print the last value here. Is that it? Let me see. Okay, stop. Let's go back to part 1. No, I don't. That is weird. That is really strange. Because I print out this, then I do the first transform, and I print out n, and I do this. Let me see. 55 goes to 82, and then, okay, wait. How come I have 55 here and it doesn't print that? That doesn't make any sense to me. That is weird. could that be? Did I copy paste this wrong? I don't think so. Okay, this is really strange. Let me try to see what this can be. 55. See? It doesn't print the last one here. I don't... This doesn't make any sense to me. That's so weird. Okay, let's add a new tab here. Save this. And now I'm just going to, because it's starting to, it really doesn't make any sense. Boom, 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 boom. So let's do 14, 13, 14, 55, 79. Okay, so this is exactly the same as it was. So if I look back at this, like 55 still tells me 82, which is weird. See, exactly the same. But if I switch back to the input, and I have a different, that's not how I should do this. So this is 79, 14, 15, 79, 14. I just wonder if there's something that's about the order that I changed in the data or something. 55 and then 13. Yeah, that is fine. See, now I get different values. So there is somewhere in my code where I mutate something that is not correct, which is very freaky. So 79. See, these last two here are different. So the last path that it takes here, for some reason, and here as well, it takes a different jump. So it goes 55, 70, 70, 53. Oh wait, Jesus, there's an off by one index somewhere with the transforms, I think. But how is that possible? That doesn't make any sense. So if I now have the values hard coded and run it again, wait, no, this does make sense. Jesus, I use index here. Okay, never mind, I'm an idiot. It's because I use this one that it shifts all the other values. Jesus Christ. Okay, so that sent me on a wild goose chase, which is annoying. So now I should also be able to do this. Okay. See, sometimes design choices that you make that seem like a smart thing to do come bite you in the ass. I was like, now I don't have to hard code all these numbers. But yeah, if you forget to run the original indexer, you mess up all your mappings. Okay, so back to the drawing board we go. Okay, so now we have this. Let's see what this does.
Yeah.
And if we compare that to the other, I think I closed that. Let's add another window here. Boom. Okay, different, better. This range is still wrong. At least now some things make sense. This is wrong. Let me see, because first let me check that the values that are spitting out here correspond with our reference data. 13 maps, we don't have 13, but we have 14 that maps to 43, that's still correct. We have 55, that should be 86, that is also correct. We don't have 79, okay. Okay, so at least we're back to some working code. Only fact is that this path, everything that ends up with a value lower than 46 is wrong. And the funny thing is that our code actually had a range that started with 46, but we don't have it here. So I wonder what that could be about. So now I wonder if there's something else about the, if I can misalign the transform index in some way, because this make faction should always have the proper final references. I did that, final references. Have the transform index there. So every time you do this, you should pass, and when you go deeper, you should pass along the next level. And I think this is all correct. So yeah, I think I need to step away from this because I've been at it for quite a bit. So I will probably go have some coffee now, talk it through, and then maybe revisit it later. Because yeah, I need to clear my mind for a bit. Because the fact is that there are big ranges here that don't add up, and I'll need to debug that, but not now. So thanks for keeping me company for a bit, and I hope to see you.